Okay, here we go. Let's review for the RAD test without the calculator. Da, da, da. So it's going to be on Delta Math. And I just went ahead and screenshot some sample problems from each type that you're going to see on the test. So let's go over these. Some of them are going to be super duper easy and some of them not so much. So let's have fun. So here, this is a straight up square root of 16. We know square root of 16 is 4. But then when we're looking at the x to the 5th, the square root says how many groups of 2 are there in 5? Well, there are 2, right? So we have the x squared. Once again, if we wrote it out as 5 x's, right, who gets to come out? One set of 2 gets to come out. Another set of 2 gets to come out, right? So x times x is x squared. Who's left over? An x. All right, is that there? 4x squared square root of x. There we go. All right. Let's go ahead, and what we're going to do first is simplify this first, and then we can multiply it by what's left out here. Square root of 8, if I stopped and did a little factor tree, right, I have 2 and 4 and 2 and 2. So we've got 3 2's underneath there. The rule is if there are 2 of you, one escapes, the other one has to be left behind. So already I've got the 2 underneath. I'm going to leave some space and the 2 left behind. When I look at the 7, switch colors. So when I look at the 7, I'm saying how many groups of 2 are there in 7? And there are 3, right, with 1 left over. And then when we look at the y, we are looking at how many groups of 2 are there in 3? There's 1 group of 2 with 1 left over. Now, we can't forget that what we have left is this. So all of this is going to be multiplied by what we had in front of it. Right? So now, could you have multiplied them each as you brought them out? Sure, you could have. There's a lot of different ways to do this. Let's go ahead and start multiplying. We've got 2 times 2, well, that's 4. We've got x times x cubed, that's x to the 4th. Y squared times y is y cubed. And of course, we've got this tagging along. Okay, let's keep going. So the next type you're going to see is write in simplified form. This is super easy. This tells me that I need groups of 3 to escape. How many groups of 3 are there in 11? There are 3, right? 3 goes into 11 3 times. How many are left over? There are 2 left over, so that's r squared. And when in doubt, you could always do your 11 r's. I'm not going to, but that can explain why there are 2 r's left over and 3 groups of r's got to escape. It makes sense. All right. So it looks like we've got, now I went ahead for each problem. I took a sample from each problem, and it looks like the beginning of the test is pretty easy because we're doing the same thing over and over again, right? How many groups of 3 do we have in 8? We have 2 of them, right? So that's 6. How many are left over? 2. All right, so I'm wondering when it's going to get a little harder because we can do this. All right, a little harder, right? We've got some things going on, but we're basically so far doing the same things over and over again. I'm going to focus on this part first. So when I see the 56, I'm going to make that factor tree. I know that 2 goes into 56, there's 3, now there's 2. Let's just do 2. 2 goes into 5, 2 times, so 28, right? 2 times 28. So 2 is a prime number, we're going to circle that. 2 and 14, 2 is a prime number, we're going to circle that. 14 is 2 and 7. So our factor tree gets everything down into the prime numbers, right? So we have 2 times 2 times 2 times 7, and it's a cube root. Let's go ahead and just rewrite the x and the y's. All right. And so let's see who gets to escape. Let's see. The rule is there has to be 3 of you, so the 2 gets to escape, right? The 7, sorry 7, you have to stay in there. With exponent, it's about grouping. How many groups of 3 are there in 6? There are 2. So x squared is out. There are no leftovers, right? Nothing's left over. How many groups of 3 are there in 9? There are 3, and nothing's left over. So the only thing left in the cube root is the 7. So what we're going to do is we're going to take, I'll rewrite it. We can even use a different color. So we're going to take this, the x cubed y squared, and we're going to multiply it by this, but we're going to clean that up. That's 2x squared y cubed, and then the cubed root of 7. So as we're multiplying we're going to do, we just have a 2, and then x cubed times x squared is x to the 5th. Y squared times y cubed is y to the 5th. And then we've got this cube root of 7. Now, it's possible as I am talking and writing that I may make a mistake in this video. So if I do, tell me, and I'll put a little note on the video. All right, so I just feel like we're doing the same type of problem over and over again. So we're going to start this test out really strong because this is just grouping. Square root is saying how many groups of 2 are there? Well, how many groups of 2 are there in 16? There are 8. All right, I'm looking at this like, wait, is the test this easy? I think in the beginning it is, right? And here we go. We continue to have these easy problems, and that's okay. Why not boost our score a little bit here? Square root of 36 is 6. And then square root says how many groups of 2 do we have in 6? And we have 3. Nothing's left over. We're good to go. All right. Still doing the same thing. How many groups of 3 are there in 22? Well, 3 goes into 22. You could even write it this way. 3 goes into 22 7 times, right? How many left over? 1 left over. So the 7, x to the 7th comes out, and there's 1. We have groups of 3. There's 1 left over, and that's our answer. So I'm just kind of getting bored. Okay, we got something a little bit different, but not really. We're doing the same thing. So it's okay. We can do this. I'm giving myself a little pep talk because I'm kind of getting bored because we keep doing the same thing. But we're just going to be so good at it. All right, 256. Oh, gosh. This is where actually, let's just kind of slow it down because you all do not like long division. So let's do long division over here. So we're going to do 2 goes into 256. This is how we're going to say it. We're going to say 2 goes into 2 one time. 2 goes into 5 2 times, but doesn't go evenly. So we're going to have to say 2 times 2 is 4 with 1 left over. Bring down the 6, right? 2 goes into 16 8 times, and we're done. So that's 2 and 128. 2 is a prime number, so we're good there. Let's pick a different color. So now we've got 2 goes into 12 6 times. 2 goes into 8 4 times, right? And then when we see the 64, we're kind of like, okay, that we can do 2 and 32. Oh my gosh, we're going to be doing these 2s forever, right? 2 and 16. Okay, I'm done. I can't. Let's extend the page. I'm complaining on the record. 2 times 8. I almost circled 8. No, I just want it to be done. All right. So many 2s. How many 2s do we have? 1, 2, 3, 4, 5, 6, 6, 7, 8. 8 2s. Holy cow, there are 8 2s. All right. So we're going to rewrite this. There are 8 2s. 1, 2, 3, 4, 5, 6, 7, 8. And we've got the x squared. Let's just focus on this. How many groups of 4 do we have in 2? Because the rule is you can escape if there's 4 of you. We've got 1, and we've got 2. Now, we've worked with this so much. We should have seen this as 2 times 2 is 4. That would have made sense, right? Because 4 times 4 is 16, times 4 is 64, times 4 is 256. All right, so we had to do it the long way. It's okay. We're forgiving ourselves. X squared, sorry, there's no group of 4s in a 2, so that stays. So you see that what I did, 2 times 2 is 4. Okay, so then that's this part of it. Let's make room for the second part of it. Let's switch colors. How about we're doing the cube root? We know the cube root. We know 25 is 5 times 5 times 5. We just know that. We've worked with it so often. So then the rule is there's got to be 3 of you. So we got 5. I'm going to bring it down here, okay? So we've got 5, and then x, there's not 3 of you. You have to stand. So now what we're doing is we're multiplying this times this. If we do the numbers first, we've got 4 times 5 is 20. Oh, okay. This is finally, we're doing something that was difficult. I think people had a difficult time because then you all were writing down where you're like, well, this and this, I'm just going to write it down like this, right? That's what you all were writing down. And then Delta Math was saying no. Delta Math was withholding that coveted green check, and we were getting mad. All right, so, or at least frustrated. And so what we're going to do is this. Yes, the 20 is part of the answer, but we're going to go ahead and rewrite each one of these so that we've got, let's pick a purple, why not? Let's rewrite this as x to the, see how the x is being squared? That power goes on the top, and this fourth root goes on the bottom. So x to the 2/4 is the same thing as saying the fourth root of x squared, right? And then let's go ahead and, oh gosh, do pink. Let's rewrite this. This x, see how we don't have a power to it? It's really the power of 1, so we got to put something up here. And this is the root, so here. So now when we write it this way, it makes sense that we can combine those two x's together. And I really think this was the hardest part of the test, that people are going to be, focused on, like, what? Two bases, the same base, right? So we're going to do an x. When I'm multiplying the same base, I'm going to add the exponents. This kind of sucks because we have to find common denominators, and we haven't really done that since 5th grade. Maybe we did a little bit in the middle school. Do you think you did? All right, so common denominator is going to be a 12, right? So that means I multiplied the denominator by 3. I have to multiply the numerator by 3. We got it. And then 12, I'm multiplying the denominator by 4, numerator by 4. Now, could I have simplified 2/4 to be 1/2? Absolutely. But I was talking, so I didn't notice. So we have 10 over 12, which we've got to reduce. Delta Math's not going to like that. We don't have our calculator, but we know how to reduce. 2 goes into 10 5 times, 2 goes into 6 6 times, 2 goes into 12 6 times, so that's 5 over 6. Now, would Delta Math mind if we wrote it like this? I don't know. You tell me. That's a correct answer, or they may say in radical form. I don't know. This problem is so far up here. Radical form. So it is not going to want us to write that. It's going to want us to write the 6th root, right? That's our root, so that's where the 6 comes from. And the x to the 5th is what goes underneath here. All right, so I think I'm going to do a couple more of these. So let's just try another one. Let's see how much time we've got. 12, that was fun. All right, so here we go. Same problem. The 256, we've done this. Is this the same exact problem? Wait, tell me it's not the same. Okay, it's a little different, but thank goodness we don't have to make a factor tree because I was getting tired of that. I'm sure that's how you feel when you're doing these Delta Math problems. All right, so we know 4 times 4 is 16 times 4 is 64 times 4. We're just going to double check. 64 times 4 is right, 16, 256. So yay. We know when we put underneath here that these are all going to be 4 times 4 times 4 times 4. We could have made our factor tree, but we've already been there, done that, right? We don't want to do it again. All right, rule is if there's 4 of you, one gets to come out. The rule, and that's the rule for the constants. The rule for the exponent is how many groups of 4 do you have in 10? You got 2 of them, and you got 2 left over, right? All right, so this is the orange part, and let's switch colors. And do this in green or olive. So square root of 4 is 2, right? And then, you know what, why don't we write it down here? Square root of 4 is 2. How many groups of 2 are there? In 3, there's just 1 and 1 left over. Okay, so here is the same problem, right? It's easy peasy to say 4x squared times 2x is 8x cubed. We're good with that. The hard part is saying we got something over here and something over here. What are we going to do? All right, let's rewrite them. So this first one, the 4th root of x squared, I can rewrite as this. Now, it's going to be helpful if I simplify that. Does everyone agree x to the 2/4 is x to the 1/2? Yep. And now let's go ahead and do this one, which, right, square root of x is just x to the 1/2. So I'm going to rewrite it so that it looks like a multiplication problem, right? I'm going to have x to the 1/2 times x to the 1/2. What do I do when I have 2 bases and I'm multiplying? I rewrite the base, and then I add the exponents. 1/2 plus 1/2 is 1. Do I need to write that 1? I do not. Does Delta Math punish you if you write the 1? You let me know. Let me know in the comments. No one ever leaves comments, but I get it. And we're just a math class. All right, here we go. And then I think we're doing it. Let's see. I know it. Let's do that again. Let's see. Are we doing? And again. Oh gosh, I'm kind of what a 256 again. Are we just getting lucky? Because I swear I did not set these up to be. All right. I just feel like we deserve to be a little lucky, right? So we already know that's going to be 4, and then unfortunately that x squared stuck in there, and then square root of 81 is 9, and the x is stuck. So we know, all right? So now we are good to go. We're just going to do 4 times 9 is 36. We're going to rewrite this as x to the 2/4. We're going to read, and we're just doing the same problem, okay? That's rewritten as x to the 1/2. X to the 1/2 times x to the 1/2. 1/2 plus 1/2 is 1. There we go. All right, we can do this. We can do this. All right, let's see. I'm missing the, okay. Okay, we cannot subtract 2 radicals unless what's underneath the square root sign is exactly the same. So let's simplify and see what we get. The only thing that we can take out of this is how many groups of 2 do we have in 4? We have 2 of them. But that 6 is going to stay in there, right? No, there's nothing that's going to come out there. And then let's go ahead and switch colors, and let's do this part. If I look at the square root of 24, 24 is what? 2 and 12, and 2 and 6, and 2 and 3. So if I throw all of them underneath, who's going to come out? It's just a square root, so only 1 comes out. So the 2 comes out, and the 6 is left over. All right, so I'm done with this part. Now I'm going to bring down this. So I've got this part times 10x squared. So what does that give me? I'm going to put my answer up here. So minus, I've got 10 times 2 is 20, and then the x squared comes along for the right. Oh, I've got square root of 6. So now do we see that we can add this, or I'm sorry, we're going to subtract. We're going to take this minus this because, and only because, these 2 are the same. If we had square root of 6 and square root of 7, sorry, 6, 7. I don't get that. And probably in a few years when you're watching my video, you're going to be like, what? Why is she laughing at 6, 7? You know, it's just, I don't know. Ask the kids. All right. So this is 2x squared minus 20. So this is 2. We have 2x squared square root of 6. And we're taking away 20x squared square root of 6. And so, right, those x squareds had to be the same too. So we've got negative 18x squared square root of 6. Could we make it look a little bit better? I don't know. Will delta math take that? Or do you have to do this? You tell me in class, right? All right, I can see where, you know, when we're taking the test, we're like, these are a pain, I don't like them. I can see that. All right, oh, it looks like I'm gonna make us do it again. Can we do it again? Because, you know, I'm getting tired. All right, that square root of 12, I know, let's see, square root of 12, I'm just gonna simply do it over here. Square root of 12 is gonna be what? 3 times 4, which is 3 times 2 times 2. So the 2 comes out, the square root of 3 stays in. If the 2 comes out, 2 times 10 is 20. How many groups of 2 do I have in x to the 5th? I've got 2 with 1 left over. Who else is left over? The 3 is left over, the x is left over. All right, plus x. The 3 does not come out, but how many groups of 2 do I have in, I've got x times x, right? Because there's 1 group with 1 left over. There we go. And so this looks good. I just have to rearrange this. So what are we doing? We've got 10x squared square root of 3x, and we're going to add 1. If you want to see a 1, you can put a 1 there. So the only reason why we're allowed to add these is because x squared square root of 3x, x squared square root of 3x, they are like terms, and we're allowed to combine them. 10 plus 1 is 11. So we have 11x squared square root of 3x. That's probably the way that Delta Math would want you to put that in. All right, I'm getting tired. How many more do we have? Oh gosh, we got a lot. Okay, toughen up, Miss Overby. Let's keep going. All right, so when we have stuff like this, we are going to make it. Remember I told you about the tenths? We have 2 tenths. We can put them all in 1 tenth. That is the same thing. All right, and so we're going to simplify what's inside. we're going to simplify this stuff first. So here we go. 75 divided by 3 is 25. 2 minus 1 is 1, so that's x. 4 minus 1 is 3. And now, bloop, put the square root. Square root of 25 is 5. Unfortunately, x, you're stuck in there. How many groups of 2 are in 3? There's 1. Who's stuck in there? The x and the y. Once again, I'm going so fast, and I'm getting tired, so if I make a mistake, tell me. I'll just shout it right through. All right, here we go. With these, we cannot do these until we switch them to exponent form instead of radical. So square root of 5 is the same thing as 5 times 1/2. And this is the same thing as 5 to the 5/6. All right, so they're the same basis, so we're allowed to multiply them, right? So when I multiply the same bases, I rewrite the base, and I add these two together, and gosh darn it, right, we're going to have to change that 1/2 to 3/6. We add it to a 5/6, and we get 8/6. Is that answer there? Oh, no, the answer's not there because guess what? 8/6 can be simplified. 2 goes into 8 4 times. 2 goes into 6 3 times. Is that answer there? Woo! It is. All right, let's keep going. So I'm going to check on the time. All right, it's lengthy. All right, here we go. Same thing, we're going to work on this first. Since we're dividing, we're going to rewrite our base, and we're going to say -1 minus 5 is -6. We know to rewrite that as 1 over v to the 6th. Then we're going to take the 21st root. Okay, well, that's not going to be good. So let's go ahead. I made the mistake. Let's back it up. I made the mistake of throwing it in a radical. We didn't want to do that. We don't want to do that. So let's go ahead and let's do that and then say, how do we rewrite that? Well, it's still raised to the -6 power, but the 21st root, and they're going to expect us to know how to simplify. 3 goes into -6 -2 times. 3 goes into 21 7 times. Is that answer there? It is. We're good to go. Okay. Note that because of our parentheses, that -3 goes to both. And so you can think about it like this. There's a power of 1 there, there's a power of 1 there. And when we see power to power, we know we're multiplying, all right? So we've got 3, and then we're saying -1/3 times 1 is -1/3. And then -1/3 times 1 is -1/3. And then they are, oh, you know what? I'm not really looking at how they wanted us to do the answers, so that was not helpful, so just ignore. I should look at the answers first, right? So let's do that. I mean, what I did was right. Oh. Okay, come back. All right, maybe I should just have erased. All right, so let's do this. This whole thing, the negative, let's go through this. The negative is saying you have to go to the denominator, right? So we got rid of the negative. And then the 1/3 is saying the cube root. And that's all it wanted us to do. It didn't want us to break it down any further than that. Okay, I'm going to look at the answers next time, right? Okay, let's see what the next one is. It's gone. Uh-oh. Was there really a blank page there? Makes me wonder. All right, so here we go. This is the bossy ones, right? The 2 on the bottom says root, square root, and we're always going to do the bottom one first. So we're going to say the square root of 25 is 5. That gets rid of my 25, and it gets rid of my square root. I have the 3. 5 to the 3rd power is 125, and we know that because we know what 5 times 5 times 5 is. And I think we've got one last one. Okay, this is power to power. What I would recommend is, see how everybody's got a power in the parentheses, but 32 does not? Put a 1 there. All right, then we're going to be multiplying. So we've got 32 to the 2/5 times 1, which is 2/5. And then we've got x to the 2/5 times -20, which is what, -8. And then we've got 2/5 times 10, which is 4. Okay, and then let's clean it up. The number, once again, I'm going to be looking at that 5th root. I know it's 2, right? 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So that's going to give me a 2. That gets rid of the 32 and the 5th root. Now I've got the square. 2 squared is 4. All right, let's keep going with this. The y to the 4th gets to stay up here. And unfortunately, when you're negative, You have to go to the basement until you become positive. A little time out there for you. All right, I think that's it. Is that it? Woo! All right, so it's not too bad. I know that sometimes you're going to have to do some multiplication and you don't like the multiplication, or sometimes a little bit of division, but you can do it. I believe in you. All right, see you in class. Bye.